Hey everybody, my name is John Nahan. I'm the manager of Energy and Earth Sciences here at the St. Louis Science Center, and today I am so excited to take you behind the scenes at our fossil prep lab. We're going to explore how a dinosaur fossil comes from the field all the way back here and then to a repository after. So let's go ahead and head on in and check it out. Really quickly, before we start looking at fossils, I just want to tell you kind of what happens in the field. We have volunteers that go out to Jordan, Montana, to the Hell Creek Formation, and they start looking around for eroded areas of ground. That means places where the ground has slowly been deteriorated over time, exposing different geological layers. They look for float, which is tiny little pieces of dinosaur bone, to start identifying where there might be some more complete skeletons around. Once they start digging, they generally find things pretty quickly. They primarily find Triceratops, Hadrosaurs, and some T-Rexes whenever they're getting super lucky. So I'll show you what they do. Come on over here with me. We'll check out what it looks like whenever they bring a fossil back from the field. It is generally inside of a cast like this. There's a little bit of aluminum foil wrapped around it. Then they take plaster of Paris, dunk some burlap sacks into it, and put a cast over it. Whenever it comes back to the Science Center, they cut it open and reveal what they found. Now, this fossil has been worked on already, so I want to show you one more right here that is in its early stages of being prepared. So you'll notice that it doesn't look very smooth, right? There's a bunch of different stuff on it. You can see even when I run my finger across it, clumps of dirt and other material starts to come off. So that's where these tools come in. Think about whenever you have to clean your bones pretty much every day, right? I'm talking about brushing your teeth. You use a brush. So these cool little brushes here have different stiffness of bristles. They go in, get a lot of the dirt off with these. The harder pieces, they use smaller picks and tools specially designed for cleaning fossils. Once they have it cleared off of all that other stuff, they use something called a stabilizer. So that's what this is. They go through and they put stabilizer in the little cracks and over the top of the fossils so that the insides of them can get really, really hard and stay preserved. After that, they begin gluing the fossil together. So what you'll notice is that there's a whole bunch of different cracks, right? This is like the most fun 3D puzzle that you've ever done in your life, and the most challenging. You'll notice there are different loose pieces that maybe fit in different areas. For example, this one is probably going to end up in a crack here, but before it can be glued on, they have to find a perfect or almost perfect fit. I'll show you in a minute what they do whenever there is no fit, and we'll take a look at what that looks like. But as you can see, all of these different pieces of fossils, everywhere where there's a little crack has been glued together. Okay, I want to take you guys to the next step. Like I said, this is a worked on but unfinished fossil. What they look like whenever they're one more step along is right over here. So I'm going to take you over to a Triceratops frill. So if we're looking at a Triceratops, we're talking about this piece back here, their head plate right behind their horns. If you zoom in a little bit and check this out, what we can see is that there's a whole bunch of white stuff in here. That is called paleosculpt. This stuff is like a really, really hard putty that's easy to work with at first, but then it turns into a really, really hard material that's just about as strong as the fossil itself. Not only does this help hold the fossil together, but it also can help us fill in those missing gaps to see what the general shape of the bone might look like. Even with a fossil like this that was really well documented, really well transported and taken care of, there are still pieces that we have no idea about where they go. So you can see that Rick, one of our volunteers, has put some question marks on here. That means that he couldn't identify the exact space where these little pieces went. But what he'll do is pick it up, look really, really closely at it under his magnifying glass here, and try to identify some colors and some lines that may give him a hint as to where it went on this larger fossil. Once he figures that out, he'll either glue it on with that glue that I showed you, or he'll try and fit it with that paleosculpt. So I'm gonna go ahead and put this back here. Now, I'm gonna show you what fossils look like whenever they're completed. So come on over this way. This is an upper jaw of a Triceratops, of a young Triceratops. So think like it was probably, and it's about to go to college, kind of later teenage years. So not quite fully grown, but definitely not a juvenile anymore. Now, something that's super cool about this is that you can really see the shape very well, right? You've got that paleo sculpt in there that's holding it together. You can see the different pieces were glued together. Some of these lines were areas where there were blood vessels, which is really cool. We can identify that. This is the jawbone coming down where it would connect to the lower jaw. There is a little tooth plate down here coming down, and then up here is actually its nose, which is pretty neat. So as I said, Triceratops are really common. We have a lot of different Triceratops fossils that we have prepared, but we also find a lot of hadrosaurs. This is a hadrosaur vertebrae. So if you feel your own spine back here, you'll notice that you've got a whole bunch of different little bumps. They're kind of small, right? Hadrosaur vertebrae are obviously a lot bigger. What's interesting about this piece is that we can see this hole where the spinal cord would have gone through, which is pretty neat. So it gives us an idea of what each individual vertebrae looked like. Next to this, we have a hadrosaur jawbone. What's super cool about this one is that as our volunteer Woody, Gene Woodford, was putting this together, he noticed, there's kind of this weird indention. Let me turn it around so you can see it a little bit better. He said there's this weird indention right here, and it doesn't really make sense. All the pieces are there, but they seem to be crushed. So as he was getting close to completion, he noticed, you know what? That looks like a tooth bark. He picked up a cast of a T-Rex tooth, put it in, and ended up with a perfect fit. So this is really cool because it tells us something about life in the late Cretaceous era. So we can maybe guess that a T-Rex at some point bit a hadrosaur and created this indention. This is something that's really fascinating because we don't often get this lucky to see interactions in between dinosaurs. Generally, we can figure out little teeny clues, but this will help us paint a bigger picture of the ecosystem back then, which is really neat. So I'm gonna take that out and put that here. So this is a T-Rex tooth. I've got another one here that's pretty cool. This is a very well-preserved T-Rex tooth. They come in all different shapes and sizes. This is a slightly larger and thicker one, and keep in mind this is just a piece down on the end. The whole root with everything together is generally about the size of a banana, which is really large for a tooth. Something that's cool about this is that it's got teeny little serrations along the edge here that are really, really well preserved. So once again, this is a really cool T-Rex tooth. You'll have to come to Science Center and check it out. And that is about everything that I have to show you all today. Once the fossils get put together like this, something I did want to mention is that they go off to Emporia State University, where they sit in a repository, and they are available to pretty much any paleontologist across the country who wants to come and study them, which is really neat. So we're just kind of a stopping point for these fossils to be prepared, cleaned up, put together, so that scientists, paleontologists can study them in greater depth. Now, really quickly want to speak towards the importance of paleontology. One of the major things it does for us now is it tells us how life responds to massive changes in their environment. So as the climate was changing during the Mesozoic era, we saw different extinction events, we saw new types of animals evolve and become very common, and we can use the way that they reacted to those climate change events to help inform us what we know about how life is going to change today. Modern life is going to change in response to the environment changing now. So thank you so much for joining me here behind the scenes at the Prep Lab. If you have any questions, please come visit us. We always have a volunteer here on Thursday who is actively putting together fossils, and any of our educators here on the lower level or anywhere else in the building would be happy to answer any questions you have. Once again, my name is John Nahon, and I hope to see you here soon.